Hello my dear young physicists. Welcome back to the world where science meets imagination. Today we are going to take a little leap, not from the ground but from the top of a tower. So here we start with the horizontal projection from the top of a tower. For this, let us consider a body is projected from the top of a tower with some initial velocity u. Okay, so for this, let me drop out the diagram. So, children, let us consider a body is thrown horizontally with initial velocity along horizontal axis be u. Okay, and this body is projected from the top of a tower. Let us name the top tower as OA. Let the height of the tower be some h. Okay, let h be the height of the tower from O to A. Let us suppose that the height of this tower be h. Okay, the angle of projection is 0. What is the angle of projection, children? 0. Why 0, children? Previous classes we have discussed that a body is projected into air making an angle theta with the horizontal. Angle is made with the horizontal. But if the body itself, instead of projecting with certain angle, if it was projected along the horizontal, then that value of theta must be 0. So whenever a body is projected horizontally, the angle of projection is taken as 0. Is that okay, children? Well, but as long as the body moves horizontal along the horizontal axis, there is no effect of acceleration. That means acceleration along x-axis, horizontal axis, is always 0. Okay, so as there is no effect of gravity along the horizontal axis, the velocity along the horizontal axis remains constant. Hence, the final velocity along x-axis remains constant, is equals to the initial velocity, that is u. So Vx is equals to ux equals to u. Throughout its motion, its velocity remains constant because there is no effect of gravity along the horizontal axis. Now if we discuss something regarding the vertical motion, then whenever the body is falling along vertical axis, then it is nothing but a freely falling body. Okay, it is an example of a freely falling body. For a freely falling body, the velocity, initial velocity along vertical axis is 0 because of freely falling, the initial velocity is 0. But as it falls downwards, because of the effect of gravity, its velocity increases and it gains some other velocity, it attains some other velocity, new velocity, say Vy, where Vy is greater than Uy. Okay, so two conditions I have discussed, children. So the body is projected horizontally. As long as the body is in motion, then the velocity remains constant throughout its motion because there is no effect of gravity along the horizontal axis. Whereas if you discuss regarding the vertical motion, during the vertical motion, the initial velocity, it is an example of a freely falling body. So initial vertical velocity is 0 and gradually it gains certain velocity. Its velocity increases and finally its velocity at some point P, let us name at this point some P as the velocity be some Vy. Okay, well, so let us observe the motion, children. So this at this point here, the body projectile has started its journey. It covers some horizontal distance as well as it also covers some vertical distance. If we discuss its velocity at point P, let us see what happens. Okay, first of all, along horizontal axis. Along horizontal axis. If you consider the along horizontal axis, from the formula S is equals to ut plus half at square, along horizontal axis means you have to consider that Sx is equals to uxt plus half ax into t square. Let x be the displacement along horizontal axis. Let the x be the displacement along horizontal axis and y be the displacement along vertical axis. This be y, the vertical displacement, let us consider it as y. This which is equals to y, and the horizontal displacement let us consider as x. So substituting in the above equation, Sx is taken as x, which is equals to, what is the initial velocity, children? Here I have discussed initial vertical velocity ux is nothing but u. Okay, the initial velocity is u. And let us suppose that the time to reach from point A to point B be some t. So this be t plus half. Acceleration along horizontal axis is taken as 0. Acceleration along horizontal axis is 0. So this is 0 into t square. Therefore, the value of x is found to be ut, or from this we have t can also be written as x by u. Keep it aside. So, if you consider the motion of the projectile only along horizontal axis, we have the equation as x is equals to ut. From that, we have also found the value of t as x by u. Now, let us discuss something regarding the vertical axis. So, along the vertical axis, let us consider the motion of the projectile along vertical axis. Along the vertical axis, the displacement is taken as Sy is equals to uy into t plus half ay into t square. But as long as the body is moving in the vertical direction, its displacement in vertical direction is taken as y. So replacing Sy as y and uy, initial velocity during its journey for a vertical motion, then initial velocity is taken as 0. So ui is taken as 0 into t plus half acceleration. So acceleration, the body is pulled downwards due to the effect of gravity. So the acceleration due to gravity along y-axis is taken as g into t square. Hence we got the value as y is equals to half g t square. From the above equation 1, let this be equation number 2. Okay, so now let us try to substitute from equation 1 and equation 2. Substituting the value of t from equation 1 in equation 2. So let us replace the value of t as x by u in equation 2. Then the value of y will become y is equals to half g. T is taken as x by u. T square means x by u whole square. Hence y can be written as this is g. This is x square and denominator we have 2 and this is u square. This can be written as 2gx square by 2u square. Let us keep it in bracket. If you suppose that g by let k is equals to, here g is acceleration due to gravity having a constant value say 9.8 meter per second square on the surface of the earth. U, the velocity with which the projectile, the body is projected horizontally, okay, and 2 is constant. So as all values are constant, so let us replace the complete constant with letter k. So let g by 2 u square is taken as k. Substituting the above equation, we have have y is equals to kx square. Hence, this equation represents this is an equation of a parabolic equation. So we can say that whenever a body is projected horizontally from the top of a tower, then the path taken by the projectile is a parabola. So we have proved that. Okay, so based on the above concepts, let us try to derive the values for time of. See here, earlier cases we discussed both the time of ascent as well as time of descent. But in this case, the body is projected only from the top of a tower. So there is no time of ascent. There is only time of descent. So let us try to find the value of time of descent. And let us also, the horizontal distance covered by the body is called as your range. Okay. So this distance from here to here until it reaches the ground is called as your range. So let us also try to find out the range. And throughout its journey, at some point P, it attains certain velocity. So let us also try to find out the velocity attained by the body at some point P. Okay, children. So first of all, what is the equation, children? Y is equals to kx square. So let us try to find out the value of time of ascent. Indicated with the letter time of descent. Indicated with the value formula TD. Okay, so children, we know that from the, what is time of descent? The time taken by the projectile to reach the ground from the top of the tower. In this case, to reach the time taken from this pink color, the complete journey from here to here, this complete journey, whatever time it takes is called as your time of descent TD. Okay, so based on that, what is the time of descent? The time taken by the projectile to reach the ground from the top of a tower. Okay, so for this, let us consider that S is equals to ut plus half at square. Formula S is equals to ut plus half at square. During the vertical motion, it is replaced by Sy is equals to Uyt plus half Ayt square. So during from here to here means what is the vertical distance, children? The total vertical distance here to here is taken as h. Hence, Sy is replaced with h. And the initial vertical velocity as an example of a freely falling body. Hence, Uy is taken as 0 into some time of descent, whatever it takes, plus half acceleration in the vertical direction, downward motion is taken as g, and this is TD square. So 0 into anything is 0, hence h can be written as half g TD square. So bringing the two other side, 2h and g downwards, 2h by g is found to be TD square, or taking the square root of that, root over 2h by g is found to be the value of time of descent. Okay, children. So the formula for time of descent is verified as root over 2h by g. It only depends on the time taken to reach the ground from the top of a tower, only depends upon the height of the tower and the acceleration due to gravity. It does not depend upon the initial velocity with which the object is projected. So it is independent of you. Time of descent does not depend upon the initial velocity, independent of you. Moving ahead. Well, so let us try to find out the range of the projectile. What is range, children? The horizontal distance, the maximum horizontal distance covered by the projectile. throughout its entire journey. That means from here to here, the maximum horizontal distance covered by the projectile throughout its entire journey is called as your range. That means horizontal. So in order to consider the range, we have to consider the formula along horizontal axis. So along horizontal axis, we have to take the formula, the distance covered means S is equals to ut plus half at square along horizontal axis. That means Sx is equals to ux into t plus half ax into t square. Along horizontal, so this is nothing but until point P I took it as x, but until it reaches the ground means I have considered it as r. So replacing the value of Sx with r we have, and the horizontal, while the body is thrown horizontally, the initial velocity is taken as u into the total time taken to reach the ground is nothing but time of descent plus half acceleration along horizontal axis is 0 into td square, and 0 into anything will be 0. Hence we found that r is equals to u into td. Substituting the value of td in r, we have r can be found to be u into root over 2h by g. The value of r is found to be u into root over 2h by g. Is that clear, children? I hope this is clear. Well, so the time of descent is found to be root over 2h by g, whereas the range of the projectile is found to be u into root over 2h by g. Time of descent is independent of the initial velocity u, whereas range depends on the initial velocity of projection u. So that only makes the difference. Now, let us also try to find out the velocity after reaching a point P. Okay, so whenever the body reaches certain point P, let us try to see what happens to the how much velocity it would have gained. Velocity after time t. In this case, children, if you observe this, the total time from here to here is taken as time of descent. But at certain point, say P, the time taken would be some time, that is t. Okay, after time t, the body is at a point P. So let us try to find out the velocity at this particular position. That means the body was reaching down. The body was reaching down. Okay, so whenever it reaches down, so we would like to find out the velocity at point P. The velocity at any point is given as the tangent drawn at that point, and this is represented as v. So this v can be resolved into its two components. One is horizontal component given as vx and vertical component given as vy. This velocity vector makes an angle theta with the horizontal. Okay, velocity vector is making some angle theta with the horizontal. So clearly from this figure, we can say that, okay, if this is Vx, Vy and this is Vx, then V can be clearly given as Vx square plus Vy square. Okay. So what is the velocity, children? The net velocity at that particular point P is given as root over Vx square plus Vy square. So based on that, let us try to find out the same. The net velocity at point P is given as root over Vx square plus Vy square. From the first equation of motion we have V is equals to U plus at. If you would like to find out the velocity along x-axis, it should be replaced with Vx equals to Ux plus Ax into t. But as long as the body is traveling in the horizontal direction, acceleration will be taken as 0. So no net acceleration acts on. Hence the value of Vx is equals to Ux, initial velocity is u, Vx is equals to u. Similarly, if you consider the vertical direction, along the vertical direction, we have from the first kinematic equation, that is V is equals to U plus AT, along vertical axis is given by Vy is equals to Uy plus Ay into T. Hence, Vy is given as the initial vertical velocity is 0 plus acceleration is taken as G into T. Hence, the value of Vy is taken as Gt. Substituting the value of Vx and Vy in the above equation, we have V is equals to root over Vx square. Vx square means U square plus Vy square means G square T square. So, this is the net velocity as the point reaches some point P in its journey. Also children, the angle made by the projectile at that point P. If you would like to find out the angle made by the projectile at this point, so instead of theta, I would like to replace it with some alpha. Some other angle I'll take. Let us represent that angle as some alpha. So, in order to find this angle alpha, what we have to consider is tan alpha. Tan alpha is equals to, what is tan alpha children? Opposite by adjacent. Opposite it is Vy and adjacent is Vx. So, tan alpha is given by the formula Vy by Vx. Okay. So, in the same case, if you consider tan alpha, then tan alpha must be given by Vy by Vx. What is Vy? The value of Vy is given as Gt and Vx is given as U. Gt by U. Hence, alpha is taken as tan inverse of Gt by U. The value of alpha, the angle made by the projectile with horizontal axis, is given by alpha equals to tan inverse of Gt by U. Remember children, in this case, the time of descent is nothing but the total time of flight. So, from the entire journey from here to here, generally we indicated it time of descent. But this is the only time taken by the projectile to reach from the top of the tower to the bottom. So, hence time of descent can also be considered as the total time of flight. Okay.